In this video, I want to go over some other useful properties of triangles that we haven't covered in other videos. First up, the longest side of a triangle is opposite its largest angle. The shortest side of a triangle is opposite its smallest angle. So in the figure, we have a triangle with side lengths of A, B, and C, and angle measures of x, y, and z. If we're told that x is greater than y is greater than z, then we should be able to determine that A is greater than B is greater than C. Likewise, if we're told that A is greater than B is greater than C, we should be able to figure out that x is the greatest angle measure, y is the second greatest angle measure, and z is the smallest angle measure. Next, the height of a triangle will always be the measure of a perpendicular line segment that is drawn from a vertex of the triangle to a point collinear to a side of the triangle. The reason it's phrased that way is because in the case of obtuse triangles, you won't have the line for the height actually hitting a point on the base. It'll be somewhere outside of the base. Regardless, this is a useful property to know because it will allow you to draw in a 90-degree angle whenever you're given the height. Last up, the length of any two sides of a triangle always add up to be greater than the length of the third side. So in the figure, we have A plus B is greater than C, A plus C is greater than B, and B plus C is greater than A. This property is commonly tested on the ACT, so let's do a problem. A triangle has one side of length 3, one side of length 5, and one side A of unknown length. Which statement below is most accurate about the length of A? 3 is greater than A is greater than 5. Well, that tells us that A has to be between the two given lengths. This is certainly possible, but I don't know if it's the most accurate statement. A is equal to 4. This is a tricky answer because you might accidentally think that this is a right triangle with side lengths of 3, 4, and 5, which is a very common right triangle. However, we don't know if this is a right triangle, and we certainly don't know if A is the middle length side. A is equal to the square root of 34. A could be equal to the square root of 34, and it would equal the square root of 34 if it were the hypotenuse of a right triangle with side lengths of 3 and 5. But again, we don't know that A is a hypotenuse of a right triangle. 2 is less than A is less than 8. This looks most accurate, because if A were equal to 2, then we would have a length of 2 and a length of 3, and together those would equal 5, so A has to be greater than 2. And we have lengths of 3 and 5, so if we add those together, we get 8. So A would then have to be less than 8. So D looks correct.